All right. Today we're gonna finish up chapter 6. Today we're gonna hit the last section. Today, in my opinion, is the hardest. Even though honestly, it's not terrible as soon as you get it. But today we're going to continue with triangles. The difference is today we're going to be making triangles on graphs. But after we make them, we have to then determine if the triangle is a right triangle. So last year, when I was watching one of the ACT tests, I was just peeking over the shoulder of a kid who's one of those pre-ACTs. And this question was on it. It gave you 3 coordinates, and it said, do these make a right triangle? Now, so for example, here's coordinates. And I want this down inside your journal, so you guys, just one example is good enough. But I want it down. So if I gave you coordinates, so let's say this is P, which is -7, 2. I'm copying this one out of Alex right now, just so you guys can see what one of them is going to look like on your homework too. So it's going to give you 3 sets of coordinates. All right, you're going to look at them and you're going to say, do these form a right triangle? Right? So I'm going to teach you how to be able to do this to be able to determine if these do in fact form a right triangle. Everyone ready? Okay, so the first thing we're going to do is we're going to identify, we're going to graph this, because I always like graphing it first. So we're going to graph this, and I'm sorry you're going to have to deal with my ugly graphs, but it's part of life. So -7 and 2, -3, 4, 5, 6, 7, 8, 9, 10. -3, 10, and 0, -2. I don't know what the title would be. Graphing right triangles. Okay. So now we graph this, right? This is P. That's Q. That's R. Now there's 2 different ways you can go about this. The question is, does this make a right triangle? Now look at this. Does that look like it could be a right triangle? What angle looks like it could be a right triangle? Angle P right here, right? Does everyone see that looks like it? But we don't know, right? You can't make that assumption because honestly the angle could be 89.93 degrees. It doesn't tell us it's a right triangle, so we have to then figure out if this is in fact a right triangle. So what I'm going to do next to these, so the very first thing you're going to do is identify which angle could be the right angle. You can see it, right? This one's not even close, this one's not even close, that one, and I'm going to dot it, because that's the angle we're looking for, even though we don't know if it's right or not yet. So P is -7, 2, Q is -3, 10, and R is 0, -2. Okay. Before I teach it, maybe I'll ask you if anybody other than Andy, maybe even Andy, can anyone determine how we could determine if that is a right angle right there?
Figure out the 2 sides, all the sides,
okay.
And take PQ and PR and use the diagonal.
Okay, so that's one way. So you could use the distance formula to find the distance between these. Or there's one more. And I like the second way. That way is okay. I'm not a big fan of the distance formula. What's another way to be able to figure out if this thing right here is a right angle? Yeah, that's what he said. We don't need to do that. Hey, there's another way. Quiet, Tyson. Think about it. There's one more way to be able to determine if that is a right angle. Max, how? How can I determine if this is a right angle?
I don't know.
Tyson, how? What did you say? Okay, here we go. We gotta think back to math 1 right now. Guys, we gotta stop talking or I'm gonna keep up on your homework. Trust me, this homework is no joke either. One problem's like a 5-minute problem because it gives you 3 of these. Okay, shh. That means it's gotta be quiet from here on out. Max, that's already an additional problem. Man, he didn't listen. Okay, here we go. Okay, so there is another way to be able to determine if that is a right angle. So these 2 lines are the lines that are in question, right? Are those 2 lines, what's another name for if they make a right angle? They're legs, but what's another name if 2 lines make a right angle? What's that called? Perpendicular. Okay, now think back to math 1. How come, what? No, let me think of it. Yeah, there it is. Say it louder.
The slope.
So the slope is another way to determine if 2 lines are perpendicular. So what we're going to do is we're actually going to find the slope of this line and the slope of this line. How will I know if they're perpendicular?
If they're,
Inverse with the sine. So look, if the slope of one line is 1/2, flipped would be 2, perpendicular would be -2. So remember, perpendicular slopes are flipped with the sign change. So we're going to find the slope. So this is the slope between P and Q. So the slope formula, if you remember, is y2 minus y1 over x2 minus x1. So P is -7,2 and Q is -3,10. So we need to find the slope between P and Q, meaning we need to find the slope of that line right there. So we can find it by going 10 minus 2, this is our x1, our y1, our x2 and our y2, over -3 minus a -7, which gives us 8 over 4 or 2. So we know the slope of this line, and I'm going to label it as I go, is 2. Now, you could count up and over and whatever not, or you could count all the way over and up, right? And you could figure out the slope. I like just finding the slope. It's easier than counting and trusting my counting ability because sometimes it's not great. All right, so that's 1. Now we need to find the slope of this line. We don't need to find the slope of this line over here because that's not, we're looking for this intersection right here to determine if it's a right angle. Remember, if it's perpendicular, then it is a right angle. So now we need to find the slope between P and R. So P is -7,2, R is 0, -2. So here we go, we're going to have M equals -2 minus 2 over 0 minus a -7, which gives us -4 over 7 or -4/7. So M equals -4/7. So is that a right triangle?
no.
No, it's not, right? Because in order, if this was 2, what would the slope of this one have to be? -1/2. Right? So if we found this one first and found it to be -4/7, this one would have to be +7/4. Okay, now look, it looks very similar. I mean, if you count it up, it would actually give you 6/4, man, or no, yeah, so 6/3. If my accurate, I think 8/4. 8/4. So it's actually really close, right? But it's not perpendicular because the slopes are different. I mean, the slopes are not perpendicular slopes. So let's do another one.
Wait.
Yes. Yeah, I'll just slide down there right there. Okay. So if I had the points, you're gonna come up and grab it later, Tyson. Here you go. No, I only wanted you only need to put, unless you want to put down 2, but later. Don't do it right now. Look at this one. T is 6/4. R is 9/10. And S is -2/8. Sorry, -2/8. If you want to, I'm not saying you need to.
Wait, is that S?
Yeah, S. So here we go. So here's our slope. Here's our graph. First point is 6, 4.
Did you solve the whole thing without graphing?
Yeah.
Yeah, you could, but I like to graph it. You don't know why? Because then you could see which two lines make the right angle. Because you can't see it right now,
Yeah.
right? And I mean, you could find the slope between them all.
What if you use the Pythagorean theorem?
You could, but then you'd have to find the distance between them first.
Yeah.
So there is options out there. I'm just telling you, and you might think another way is easier, but I'm just telling you which way I found to be the easiest. So 9 and 10, -2, and 8. Okay, there's our triangle. This is T, R, and S. Alright, first off, identify which angle looks like it could be the closest to 90. Definitely T, right? So what I'm going to do is I'm going to find the slope from S to T and the slope from R to T. So, S is -2.8 and T is 6.4. And then we're going to find the slope again, 9.10 and 6 and 4. So I want you guys to go through and find the slope between those. Go for it. This is my X1, my Y1. I want to see pencils moving on papers. Go. I want to find the slope between those 2 points.
It's non-acceptable excusing.
Well, I'm ready to get it. Yes.
Remember, we're looking at this, and I always kind of like labeling it a little bit. And like I said, this is an exact problem that I've seen on the ACT. So, yep. Not the exact coordinates, but it was one like this. And it was basically a true or false. It said, these points make a right triangle, true or false. And then you had to go through and just, maybe it said, what type, it asked me what type of triangle do these things form? Isosceles, equilateral, or whatever it said, something like that, right?
So, wait, how much time do you have to do this?
I don't know. Here we go. N equals, I'm going to start going through it while you guys are doing it. Hey.
I was thinking, that's so fun. Oh,
Remember the slope formula. What is
T
it?
to S and T to R?
Yep, T to S and T to R.
I'm so blind.
I wouldn't have one now. I got it 3 times.
Wait, how can you tell it's a right angle if it's leaving out 1/2 and 2?
Huh? So, if the slopes, Tyson, which you should learn this last year, slopes, if the slopes are reciprocals with the sign changed, then they're perpendicular, meaning they intersect at 90 degrees. So do you see how this one is -1/2 and this one's 2? So the reciprocal of -1/2 is -2. Sign change would be a +2. So that you know that those are perpendicular.
Not that triangle. I can't even do
Okay,
it.
wait.
1, 2,
It's y minus y, right?
y2 minus y1 equals over x2 minus x1. Okay,
It doesn't matter.
No.
Right?
I always do y. You just have to make sure if this is your 2's,
That you keep it like
that
the
you
same
keep it the
number.
2's. Okay,
wait.
so just listen while I describe it. So we know that this one is in fact a right angle. Because the two slopes, the slope of the first line is -1/2. The slope of the second line is 2. So we know because those are perpendicular slopes, we know that they're going to cross at 90 degrees, making angle T a right angle, which in turn would make that a right triangle. So we know that that is a right triangle. Okay? Any questions so far? So step number 1, graph it. Step number 2, identify where your right angle is, or your could be right angle. Step number 3, find the slope of the two lines that form that could be right angle. And then if the slopes are perpendicular, you have yourself a right angle. If the slopes aren't, it's not a right triangle. Okay?
Oh, I didn't know.
So, do we need to write down steps? You guys want to?
Let's just wing it.
There you go. Step number 1. Here. Graph triangle.
It's not gonna help.
Just real quick.
Can you go back to the?
I will.
I definitely messed up and I don't.
Graph triangle. Step 2. Find could be right angle.
That's not what we're worried
Find slope of both lines that make could be right angle. That's it. Those are your 3 steps and you guys can do it. Okay? Hey, that's it though. 2 problems. But each problem has 3 of them.
What did it ask?
So,
That's so rude of him.
so Andy mentioned you could use the Pythagorean theorem. Andy, do you agree this way is easier? So the Pythagorean theorem, you'd have to find the distance between each point and see if it equals a squared plus b squared equals c squared.
I decided once.
Oh yeah, I love this crap.
Graph it for you.
Nope.
Guys, so rude.
Hey, the bad thing is it doesn't even give you a graph, so you're going to have to graph them out by hand. Wait till you see the questions. It makes the problems look so easy.
Why are you trying to make me cry?
Oh, it's those kinds. Okay, never mind. That one, that one.
Okay, so I wasn't really paying attention very hard on perpendicular
Well,
parts.
good luck.
Well, would you explain to me how it's perpendicular for a second?
If the slopes are